Hello, I'm Kevin Benedict, Senior Vice President of Solution Strategy, and I want to thank all you guys for joining us. I'm thrilled to have as our guest today in this episode of the Digital Expert Interview Series, Sam Lakkundi from OSIsoft. Sam, thanks for joining us.
Kevin, thank you very much. Good to see you again, and look forward to this conversation.
All right, so where are you calling in from today, Sam?
Today I'm calling in from sunny Orlando, Florida. So, they'll be seeing you in a week here at Sapphire. So looking forward.
So I'll be flying down on Monday morning. So look forward to seeing you there. Absolutely. Now, so your title here is Industrial Internet of Things Cloud Analytics Innovation Leader. Talk to us about what your role and responsibility is there at OSIsoft.
So what we do at OSIsoft, for the folks who don't know OSIsoft, is we are a historian. So that means we collect large amounts of data from assets, such as oil wells, rigs, machines, anything that is pushing out data, we are collecting. And so what we do with that data is run lots of, intelligent insights into that data. Once we get this large amounts of data, which is a topic of our conversation today. And what we are able to do with that data is put it on the cloud, run analytics on it, and do all sorts of analysis that customers find very useful. So that's what I'm focused on.
So for the purpose of this conversation today, we're talking about the industrial Internet of Things, and data all starts with something that collects it.
Yes.
The automated data capture device like RFID or barcode or sensors of all kinds. Talk to us about that. What do you see going on out there?
So, a lot of the people out there probably are aware of IoT and what the difference between IoT and what we really do and what industrial IoT is. There's quite a bit of difference, right? So IoT is what you and I know in our everyday lives, right? Our Nest thermostat, our garage door opener, my Fitbit here, which is collecting data and can give me notifications and simple things of that nature, right? I can shut off my light bulb to shut off my garage per se. So that's great. But what most companies have done for many years is collect data from assets, and these assets are basically important things such as how does an Boeing 747, how does this turbine engine, how is it performing? Is it going to need maintenance? Or how much oil is coming out from an oil rig, or so on and so on. So that is something that most customers are probably not aware of because they're the end consumers. So in my sense, I have a Fitbit, which is IoT, and I also have here a little toy. It illustrates a fact of industrial IoT. So this is a earth mower in a mine which actually collects data. But what we are doing is basically collecting vibration on the wheels, collecting, how much, what this asset does, how much payload it carries. So that's a different kind of, sort of IoT, which is a lot of people refer to as industrial IoT. For those folks who are not aware of difference between that, I think that's the majority of what most organizations and enterprises are into.
Oh, very good. So what makes that all possible is sensors, right?
Absolutely.
So I know that every year when I go to Barcelona to the Mobile World Congress, one of the things I love mostly about walking the floors and looking at the exhibitions is all the different kinds of interesting sensors and the fact that they can monitor new and interesting things. What are some of the most interesting sensors you're seeing out there right now?
So sensors, as you know, right? Back in the days of RFID, which was sort of the initial introduction to most people on what we call today as industrial IoT. So those sensors basically have had an immense amount of, futuristic features put into it, right? So going back to my truck example, here, this truck basically, I have some sensors in here. This sensor, measures vibration, for example, right? It's a very small sensor connected to a router, which allows me to basically collect that data. But this sensor actually embedded into this mining truck can collect, vibration information. It can collect, how heavy the load is or how tired. So things such as, how tired is the driver, right? I mean, just looking at his retina and then collecting that information and then slowing down the speed of the vehicle, given that he is running up, into information is these sensors have become a lifeline, right? So if you take a company like Tesla, who has, who we are all familiar with, and basically a car that runs by itself, that would have been science fiction, even 4 years ago or 3 years ago, and today is a reality, as you know. So that's where the advancement in, has sensors has gone. And because of that advancement, we are basically collecting even more data and more information and have much more intelligence based on this information.
So Sam, in your role, you're meeting with companies and leaders all the time.
Correct.
When you sit down with a company, where do you even start? Let's say they have a little bit of data collected over here, a little bit of data collected over here, but where do they start in putting together a comprehensive kind of industrial Internet of Things system so that they're getting real-time visibility into their operations? How do you counsel them or give them strategy? Talk to me about that.
So this is a very interesting question, right? Because given the fact that most companies have this data or they want to collect this data. So we went to one of the organizations who has been in manufacturing, right? And they had no idea. I mean, naturally, they have been manufacturing for almost 30 years and they've been collecting information. But how do they do make sense of that intelligence? What does IT help them in that intelligence to actually do things such as, I have my ERP in finance, I have my HR solution, right? So you say, wait a minute, how does finance and HR mean anything to data? Well, a lot, right? Because you can think about financial, your financials in the company and say, based on these financials, I'm going to actually purchase these. I mean, sorry, if the asset is breaking, I got to, assign more, monies to this division. Or HR, where basically I say, hey, I need more workforce because I'm seeing that our production has increased, but our number of people is still the same, and so they're not able to keep up. So this is how we basically make that interaction. So the great place to start, to going back to your question, is basically do some kind of a design workshop, right? Because that is really, to help people understand, where do they start with the data? How do they actually collect this information? What they need to deliver out of it is really where we actually start. Basically get into a room with all the operations guys and the information guys with the IT and OT, and just basically coming together, which I have found out in my experience has been missing, a big missing link. In large companies, the operations guys don't know what the IT guys do. The IT guys don't know what the operations guys do. To bring them in a room is a start.
Wow. Thank you for sharing that. I write a lot about Internet of Things and strategy around that. And I talk a lot about blind spots. And it seems in a lot of organizations, a lot of their operations are still blind to management. They don't really know the performance numbers. They don't really know real-time status. They don't get real-time status updates from various parts of their operations. And it seems that a significant part of getting data in areas where you never got data before is that now you can make real-time decisions on that. So what role does kind of speed of decision-making play in this whole thing?
Actually, a very big one, right? So we are talking about data that is coming out at very high volume and very high velocity. Right? Because think about it, a sensor sitting on an oil rig. So we are able to measure, you could probably even measure the viscosity of the oil, the chemical balance of the oil, how fast it's coming and how much it's really producing, right? On the other side, in a gas station, you can talk about, the consumer consumption of that oil. So again, that's happening in real time. May not be as rapid as the oil coming out from the oil rig, but naturally every time somebody's pumping gas, we're getting real-time analysis of how much, they are consuming or something is being manufactured. So the high volume and high velocity and getting that data in real time, Kevin, is something that companies have not really, got to an understanding, right? So getting this information in real time and making real time decisions on it is absolutely key to the company's, sort of long-term longevity, predictive maintenance, asset, reliability. All of those things take on a new shape because of the real-time information that's coming in today, right? Because it's not historical anymore, right? So even though we are called as a historian, that's really, a false sort of a technology word, because a historian simply means, oh, it's history. Forget about it. But the problem is that the solution that we offer is actually a lot more of a real-time insight into what is actually happening at the time of inception of that data. And that is something that is critical in most organizations today.
So I can think forward on this, and I think, okay, a company buys into the whole strategy of having real-time access to real-time data so they can make real-time decisions, but it's like turning on fire hoses, right? Suddenly getting mass volumes of data. Now, a human is not going to be able to look at all those zeros and ones and analyze and interpret the meaning and make appropriate business decisions on that. So I imagine there's a significant role for artificial intelligence, machine learning, automation, all this in that flow.
Absolutely, and I think that is something that is of huge importance. And let me actually show this via an example, right? Because it will help you understand what we are referring to. So I'm going to switch my screen out to something I can share with you, talking about real time. So what you are seeing on the screen now should be my phone. When we talk about real time, so what I can do in real time and using artificial intelligence and so on. So what I'm doing is I'm actually having a conversation with a system, right? This was developed by one of our partners, as far as how do you take the information and then run intelligence on it. So once we get the data, the sensors are providing the data, we get that data, and then what we're able to do is basically have not only a conversation with the data, but learn from that data, right? So I can have a conversation. As you see, the green part is me talking to a human being, where I ask, what is the average energy consumption of crushing conveyor belt mine 26? So it tells me that, hey, this is the average consumption, right? So it comes back and tells me. But also it's learning at this point, Kevin, because what it's asked, it's understanding and trying to understand is, wait a minute, why does Sam keep asking about this conveyor belt, which is, from mine 26? Maybe this is something that he wants to learn about. So instead of me asking, wouldn't it be awesome if it starts telling me this information, right? And so, for example, if I'm trying to, another thing, right? So if I'm basically saying, hey, it's giving me some information, say plant, blah, 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 this was used the last time. If you take a look at the statement. So it learned from my previous interaction and says, oh, looks like you meant 6544, not 6543, a plant number, because that's what you used last time. That is intelligence built in and learning from the data that is out there, right? So this is an important aspect of how asset intelligence and so on basically are playing almost a big part in how people are perceiving and taking this data. Machine learning, artificial intelligence, based on this very large amounts of data, are going to be key to most companies who are basically looking to get better insights of the data. Just like you have a chatbot who basically learns from you and then basically starts, sort of, instead of you subscribing, it starts basically pushing information to you.
So that was a powerful example of data, the use of chatbots, artificial intelligence, machine learning, the ability to communicate with the data and get insight. I can also envision systems where thousands of streams of data are coming in, but they're not coming into a human for human consumption. They're inputs to an automated system that already understands best practices and can change and adjust operations based on all those flows. Do you see a lot of that as well?
Oh, absolutely. And this is where, I think, Kevin, this is where, you hear this term machine to machine, right? Which is the ability for a machine to understand another machine's behavior. And specifically, you'll see a lot, you have seen a lot of advancements in technology where basically, based on a machine's interaction can, before a human even interacts and says, okay, shut down that valve or shut down that pump, can I actually do it before basically somebody tells me? So that's a learned behavior from, you could get this from thousands of machines and say, listen, if the PSI goes above this amount, we know that this dam has bursted. So we are going to basically make sure that we shut down the valve, and we'll inform the human, but we're going to shut this down because we know that safety is involved or production is going to be down, and we're going to do this. So I think that is absolutely that, humans will basically be sort of a monitor for what we do in the future or what's happening in the present time, right? I mean, as you know, cars start making adjustments. Like a Tesla can make a lot of adjustments before, before you basically, are able to hit a car. It's able to communicate with us with the camera and say, stop the car, because we know there's going to be an accident, for example. And that's really where I think a machine to machine is going to basically take over a lot of what even humans are able to actually feed into it. So,
yeah, I see that as one of those distinguishing differences between kind of the consumer level Internet of Things and industrial Internet of Things. In that industrial doesn't just have one user on the end looking at their Fitbit or sitting in the car looking at what their car's behaviors and sensors are revealing. It's really coming back into a very sophisticated and complex environment where automation can start implementing the best practices as defined by the humans in the system. That's fascinating.
It is, and I can cite several examples of something of this nature. So let me actually show you something which gives you a little more sense of this, right? So what you are seeing on my screen is one of basically information that is coming out from one of the sensors in a dam, right? So here's an example, right? A dam, this is British Columbia hydro plant in Canada. So it's producing, electricity, it's generating electricity. So what it's doing is, as you see, there are like many valves that are open, but there's one valve that is shut, right? So I could actually, as a human, go into that and take a look at what's happening with that valve. Why is it shut? What's going on with it? Or I could actually have the machine start diagnosing this information and basically come out and say, here's the diagnosis, because we have enough fuel. Enough electricity that is being generated. I'm just going to basically shut this off because it makes no sense for me to actually push out more electricity, given the fact that 3 of them are operating at 100%. I'm just going to open this at a 10% because it doesn't need the full, aspect of that. And that's something that, those kind of information like that, Kevin, is going to be extremely useful as, machines start deciding and then informing the humans of this information. Another key example, which I'll quickly share with you, this is an example with Esri and OSIsoft, where we basically are giving information. But if you take a look, these are earth movers in a mine. What's happening with these earth movers, as you see, is they are giving a tremendous amount of information, right? Which is things like tire pressure, brake temperature. This is in real time that they're providing this information. Going back to your previous, example, who the driver is, what the manufacturer is. But if I take this information and I am able to collect this information and share it with other earth movers, that hey, if you use this much load, your tire pressure is going to drop by this much, so you need to actually reduce your load. Wouldn't that be awesome information, right? And that kind of information, Kevin, is something that I think is extremely useful for us to realize with the machines.
Oh yeah, so it's fascinating that I think a lot of us think of Internet of Things as the ability to get data and updates and collect data from Fitbits in our homes, home automation systems, etc. But I think less attention is given to actually what you can control remotely, because
Correct.
You can build systems that can open gates, close gates, secure buildings, raise temperatures, reduce temperatures, open the dam floodgates or close them. And that is actually the response of data being sent back out after analysis. So it's not just collecting data, it's the whole analysis and then sending orders back out that actually change physical objects.
Correct. And I think that's more important, right? So if you take a look at one of the one of the places where a lot of this innovation is going on is in building and maintenance systems, right? So your HVAC unit, right? Or your fire extinguishers or your doors, like you said, most modern buildings today and most modern homes. I have a home which, came fitted with a lot of sensors, right? Whether it's outside my garage or in my my ring.com or just basically in my house that is measuring my Nest thermostat. So and it all came with the house. I didn't even have to do it. So this is a de facto effect of and so most buildings, most things today. Whether I think in a few years from now, or even actually happening right now, I think that most vehicles will start becoming autonomous. And somewhere somebody said that will it be actually legal to drive a car in 25 years from now, right? Would you need a license to drive a car because cars will be more safer by driving themselves. So that means it's machines, one car giving information to another saying that, hey, you need to slow down because I've gone through that road and there's a pothole which was going to break, which is going to rupture your wheel. So you might as well slow down and take that. A human would not know that. But learned machines can actually feed this information and make that car a lot more safer and a lot more reliable given this information.
Well, yeah, I think back when I was teaching our two kids how to drive, and one of the, kind of the rules or pieces of advice that I gave our kids is always be predictable.
Yes.
If cars coming, see your turn signal and see you slowing down and everybody understands what you're trying to achieve, then everybody knows how to react around you. It's when you are unpredictable that things get very dangerous. So I can see the advantage of when cars not only are smart about themselves, but are communicating their intent with the cars around them, then everybody's predictable. Okay, I need to take a left turn, so everybody behind me slow down because I'm in front of you. I need to turn left. And I'm talking to the car coming at me, letting them know I need to turn left and to expedite traffic. You should slow down and let me turn so I'm not, backing up traffic behind me. So all those things I can see incredible advantages to predictability.
Absolutely right, Kevin. I mean, like you said, we teach our kids basically don't text and drive and look around. And, we say, oh, the kid, he's only a 16-year-old, so he doesn't have the sense of driving yet because his brain is not fully developed to know that but a computer is learning from, systems are learning from thousands and millions of other cars. So naturally, the reality of us sitting one day and reading our iPad as a car is driving is I don't think that's too far away, right? I mean, in a lot of sense, as somebody said the other day that, hey, like I was just saying that maybe we will not be driving cars in 25 years from now at all. And you need special permission to drive a car, right? And I probably believe that's true, right? Because we are much safer with the hands off the car than on the car. So
absolutely. So talk to me about when you sit down with a company, what's the market look like today? Does everybody understand this, or are many companies still missing key parts of the strategy?
So I think that, Kevin, I think a lot of these people have started understanding that data is, like everybody says, better is more valuable than gold, which is absolutely true. And data provides them with absolute insights, and it doesn't matter what the industry is, right? Whether you're in oil and gas, whether you're in utilities, or whether you're in mining, that data has become key to a lot of these companies, and they're actually seeing that and it's always that the consumer world drives the enterprise, just like we saw in the early days of mobile, where people started booking hotels and doing banking and then, CIOs and said, hey, wait a minute, why can't I do this in my own organization? And that's what is happening. They use their Nest thermostat at home. They see their garage door, which is like fancy and can be controlled by mobile. And then they say, why can't I do that with my systems? Why can't, there's a Nest learning which says, hey, Sam is not coming, always comes in and turns the thermostat down to 68 degrees when he comes in at 5 p.m. I'm just going to do it for him. So that's like, I don't need to be in the middle of this, right? So because if I come home at 5 and turn it, it takes at least 30 minutes to really make the house cool enough. So people are realizing from the consumer world now that, you know what, we have all the system at the back. It's not like I don't have it. I have it, so might as well use it. And that's really where I think that, companies have now basically taken what they know from their personal lives, or what they have realized, oh my God, I have this massive, amazing operations that I'm already getting all this data. I might as well learn from it, might as well teach it, and might as well benefit from it. And that's really what we see as an IT/OT convergence that's occurring.
Oh yeah, I have a CUNA security system on my front porch, and one of the services that it offers in the cloud-based service subscription model is it will recognize your face, right? So then it can say, hey, your kids just got home from school, and send you an automatic notice. It can recognize cars and license plates, so it can say, hey, your 16-year-old son just got home, and all of that. It starts to recognize that through all kinds of analytics. So I could see doing that in a big factory where it recognizes the people coming in, so they don't have to punch a time card, because that actually the system already knew you were there, and so logged you in and logged you out, and you don't have to box and archive, timed and time-stamped timesheets and things like that. So talk to us about OSI. What do you guys, when you're thinking about the entire industrial Internet of Things, systems and sensors and analytics and chatbots and artificial intelligence and automation and integration and APIs, all these kinds of the ecosystem around the industrial Internet of Things, how much does OSIsoft do? Sam, did I lose you? All right, Sam, can you hear me?
Yeah, I can.
Okay, I'll ask that question again, and we'll just start fresh there.
Yeah, no problem.
So talk to us about OSI. When we think of the ecosystem of industrial Internet of Things, we're thinking about sensors, we're thinking about the data transmission, we're thinking about data security between a sensor and a backend system. We're thinking of APIs and integration with ERPs and plant maintenance kinds of systems, all these different things. Talk to us who are watching right now. What role does OSIsoft play in all that?
So what we do, Kevin, is our role is to basically, so what we do is two important things, right? 2 or 3 important things. The first one is collecting the data from the actual sensors, which is the most important thing, right? So, but we are not a hardware company. We are basically a software company. So what we have done in the 37 years OSIsoft has been in business is actually, create a lot of connectors to the controlling systems that are interfaced with the sensors, right? So we don't connect to the sensors directly. We connect to the controllers that connect to the sensors, right? So these are systems like Rockwell, Emerson, ABB. These are the guys who make the controllers. So, but we are the largest vendor who actually has the most amount of connectors to these like controlling systems, right? Where we pull the data.
Yes.
We pull that data, Kevin, in very high, but the data is coming as I mentioned earlier, in very high volume and very high velocity. So what we have done is basically we basically literally take that data and dump it into almost a flat file, right? You can't put it into a database because a database is relational. It needs columns and rows. So it doesn't make any sense for us to actually take the data and put it into a database. So we actually collect it, and this is really the secret sauce, where we take it and put it into this large data sets, right? Almost a flat file sort of information. And from there, we have these, what we call as, a software called as Pi Vision, basically that allows us to read that data and report on it in real time. It's almost like going to NASA and looking at the control center, right? If you look at NASA control guys, they're sitting behind the screen and they're looking at like, okay, what's the temperature of the exhaust system? How much is that astronaut breathing? What is his heart rate? So those are all vital statistics coming out in real time that I'm monitoring. I can actually put all sorts of, I can actually put some kind of, information which I said, hey, if the temperature of this machine goes above this, then I want you to do this, right? So I can put, some kind of a threshold that, I'm basically saying, bing, 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 it starts like blinking saying, hey, the temperature is down, what do you want me to do? Or take action. Hey, if the temperature is down by this much, take action, start up another generator, right? So that's what we do. We basically, collect the data from the system, we store the data, and then we report in real time on that data. And that's what OSIsoft does. And that's been their bread and butter. And they've done it for literally thousands and thousands of companies. And we have about over 1.2 billion sensors. We're collecting this data in real time as we speak today.
Oh, wow. Thank you so much for sharing kind of the behind the curtains insight into what's going on and what it requires to put this together. So, Sam, I want to thank you so much. And let's continue this conversation at SAP's Sapphire Conference next week in your hometown of Orlando, Florida.
Absolutely. I look forward to being there and seeing you there.
Thank you, Sam.
Thanks, Kevin.
Take care. Thank everyone. I want to thank everyone out there for joining us today.